Buckle up because today we are diving into how a bad hinge date can explain the gut brain axis. You're not going to want to miss this episode. My name's Kelsey. I'm a board certified doctor of physical therapy and orthopedics, and then also a pelvic floor physical therapist and the host of the Wellness Big Sis podcast. If you're joining us for the first time, welcome. If you're a repeat listener, thank you so much. We're going over a lot over the last few weeks and the upcoming weeks about glucose metabolism and glucose regulation. And I feel like this is one of the reasons that we can sort of dive into the gut brain axis a little bit more. So I'm going to try and make it that much more digestible for us today. I know a lot of us have heard the terminology gut brain axis and how that gut feeling we get in our stomach is related to what we're actually sensing, even if it's in our subconscious, and how what we feed our gut can fuel how our brain responds to things and reacts, and our processing speed and our way of repairing the brain and different things like that. So today we're going to dive into that a little bit more and hopefully clear up a few things and make it as clear as we can. And I thought a bad hinge date is the perfect example. A little bit of an overview, a little bit of a debrief. The previous episodes, if you've missed them, the first one was the Hot Girl Walk episode, all about how movement affects our glucose metabolism and our glucose regulation. The second one, all about fueling and how the order in which we eat our foods affects how our body metabolizes glucose. And then the most recent one, how sunlight and sleep affect our metabolism. And all of them are just super cool ways of showing how the body truly is magical. So we're going to continue that today with the gut brain axis, natural ozempic, and just diving into all of the sciencey things with also a real life example. And so a little bit of a disclaimer, I have never been on a hinge date, so this is not, I've heard wonderful things about hinge specifically, so this is and that's why I've actually used them as an example, because I feel like a lot of my friends have found their life partners on Hinge. And so that's the dating app that a lot of my friends and cousins have used, and so that's the one that came to mind with this episode. So absolutely no hate to Hinge, I've heard amazing things, but I just thought it was a fun sort of trendy way to look at the gut brain axis by looking through it with the lens of a bad hinge date. And I got this idea actually from one of my cousins. So it sort of inspired me because she had a bad hinge date and we were just cracking up about it in hindsight. And so I felt like this was the perfect opportunity to incorporate that story in while also learning a little bit of wellnessy, sciencey, fun topic in the gut brain axis that can also be pretty confusing. So we'll go over an overview on what I mean when I talk about glucose metabolism. So we've gone over this sort of short overview with each episode, but I'm going to quickly go over it today. So when we ingest food, especially carbohydrates, our body breaks them down into glucose molecules, and our body can utilize that glucose immediately in the form of like movement and cueing our skeletal muscles to use that glucose for energy immediately. It can go into short-term storage in the form of glycogen in the liver, or it can go in the form of long-term storage. It can go in the form of triglycerides into long-term storage in our adipose tissue. And so there's a few options for where our glucose can be utilized or stored, because what we don't want is these significant peaks in our blood glucose levels or this significant variation in our blood glucose levels. So our body has these mechanisms built in that can help level out those blood glucose levels for us to keep us with decreased cravings, healthy body composition, healthy weight, appropriate just like cueing of different cells and different hormonal responses in the brain and within the pancreas. So we have insulin and glucagon, and insulin in particular is the one that's involved in helping to cue that glucose to go elsewhere, right? We want it out of the bloodstream. We want a level, like sort of a baseline level in the bloodstream. And so the insulin is cued when it goes too high above that baseline level. So that's when our muscles utilize it. That's when we store it in short-term storage or we store it in long-term storage. On the opposite side of things, glucagon, which is also a hormone and released by the pancreas, is in charge of mobilizing that glucose. So if we're ever sort of running from a bear or doing a HIIT class or something where we need that energy, that's where glucagon is sensed and comes in. So with sustained levels of blood glucose levels, again, our body's built to control them, but a lot of time that can get out of hand if we have too heavy or too high of a meal with carbohydrates in it and our body's not sensing that in the right way because we have these chronic sustained levels of blood glucose elevation. And so it can lead to things like chronic inflammation, our cells not responding appropriately to insulin, which is the hormone in charge of sort of getting it back to baseline in our bloodstream. So just a lot of bad things. Diabetes is what comes to mind too, obesity, and it's just this vicious cycle. So what we want to do and what metabolism really is sort of getting out of this vicious cycle. So controlling that level of glucose within our blood so that our system is not chronically overloaded while trying to manage those sugars, right? And so the gut-brain axis is one of the coolest things that we've found, that I think is one of the coolest things that have been found about the body, and how our gut is able to sense glucose and our digestive tract is able to sense glucose and then send signals to the brain to help respond and appropriately regulate all of the systems and all of the pathways that is involved in managing those blood glucose levels. And so we'll get into the gut-brain axis, but the key players for the gut-brain axis are the digestive tract. So primarily we'll be talking about the oral cavity, so where our tongue is, and then also the small intestine. The stomach as well too, but primarily oral cavity, small intestine. We also have the liver, which can be kind of linked with the portal vein. Portal vein, liver, those two are linked together. Skeletal muscles, pancreas, and then the hypothalamus, which the hypothalamus is the brain component of the gut-brain axis. And so to start, there is interaction between each component of the system. And a lot of the time, our body in most systems has what we call built-in redundancy. So this is true for our cardiovascular system, just as it's true for this gut-brain axis, where a lot of the time our body senses things locally, meaning it senses things at the cellular level, at a local level, like really pinpoint. But it also has a secondary signal that can help reinforce whatever it was sensed locally in order to create a systemic response. And so if I can explain this a little bit easier, this is where the hinge date comes in. So a lot of the time, if you're going out on a hinge date for the first time, you are going to have your own automatic out from the hinge date, whether that's a stomach ache, whether it's you drank too much the night before, whether it's, oh no, a family member just had an emergency. Like you locally, you as your own self has a way to get out of this hinge date if things start to go south. You also, most likely, if you're like any of my friends or cousins, also have a person to text or a group to text if things go south for them to also help you get out. So that is more of a global response, right? You have your local response where it's just you, but you also have your global response where you have this group of people who are also looking out for you external to that current environment that you're in that can also send in reinforcements. And so we have, just like a bad hinge date, we have this built-in redundancy. We have these built-in sort of ways to make sure that we are safe and that we are enjoying ourselves. And if we're not, we can get out of that situation within a good time frame without having a complete waste of time, right? So there's an interaction between each component. Most often we have a response locally, and then we also have it globally, which is where the brain part of it comes in. And so in this example, the local part of you is more of that digestive tract. So your digestive tract has what we call glucose sensors and different cells within it that help to sense glucose levels. They in turn, and again, this is broad, we'll get a little deeper, send signals to the brain, sensing an increase in glucose. The brain in turn sends signals back to the pancreas, the liver, the skeletal muscles, the digestive tract, all of it saying, okay, we need to absorb, we need to store. It sort of is that overarching control center for how we utilize and manage that glucose so that our body is prepped and primed for that glucose to come in. So we have the very start of this process starts with the oral cavity. And so as soon as we have like sugar or carbohydrate or something hit our tongue, we have glucose sensors in our tongue that senses that sweetness and can actually send a message to the brain that says, hey, we're sensing sweetness. And then the brain can send the appropriate response along the digestive tract to the pancreas in order to be like, hey, we're sensing sweetness up here in the oral cavity, up here at the top of the digestive tract. Let's get all of our reinforcements ready below so that as soon as this food hits our digestive tract and hits our stomach and our small intestine, we're able to manage it appropriately. And so the brain acts more globally via what we call the autonomic nervous system. And so that autonomic nervous system is the umbrella term for our parasympathetic nervous system and then also our sympathetic nervous system. So parasympathetic, rest, digest, super easy way to remember. Sympathetic is fight or flight. So most often in digestion, in glucose storage, we want that parasympathetic nervous system to be the one that's signaled. And so the oral cavity, I like to think about it as like, okay, so we sense that sugar. We meet the guy on the first date. We meet whoever we're meeting. We meet the person on the first date. We're just already starting to get a bad vibe, right? So we're starting to read his body language or her body language, and we're starting to realize like, okay, something's a little off and I'm not quite loving this. So that's when you yourself locally start to think, okay, I'm going to have to start acting sick because I'm already like, or at least thinking of ways that my body language can indicate sickness, even if I'm not sick, but indicate that just in case that's an out that I need to utilize. I also need to text my friends. So I need to say, hey, I have a bad vibe about this. Text sent to the brain, right? And that's what's going to help cue the rest of the response. So the oral cavity has those taste buds sense the glucose. They send the signal to the brain, which then prepares the rest of the hormones and all of the signals involved in order to manage that glucose. So one of the cool facts, or two cool facts, I guess, with this is that when glucose is administered orally versus via an IV, so when it goes through that oral cavity versus an IV, we have a 2 to 3 time increase in that insulin effect when it goes through our mouth compared to if it's injected via an IV, right? And so this is like the text coming from a table beside you with the IV to your friends. Like your friends aren't going to take it as seriously compared to a text coming from you saying, hey, I have a bad vibe. That's going to create a larger response from them. And so it's just super cool to think that is actually how we are able to know that there is a true communication between our tongue and the brain already, because the brain, the tongue cues and senses that glucose, then it sends a signal to the brain and the brain can already start that response. Compared to if it was injected via an IV, we don't have those taste receptors. And so it's a little bit of a slower transmission by the time the glucose reaches the next checkpoint in order to cue the brain on that insulin response. And so the other cool sort of second fact is with obesity, the sensitivity of these taste receptors decreases. So we might actually need to eat more sweet things in order to cue these receptors at the appropriate level. So the next sort of checkpoint along this path, so if you inject it glucose via IV, the next sort of checkpoint that will start to sense that glucose is in the small intestine where those carbohydrates are actually absorbed. And so the small intestine has cells that line the very inside of it that help to sense that glucose. And so as it's being absorbed, the concentrations are changing, meaning they're saying, oh, we're sensing a little bit more glucose. We're sensing a little bit more sort of bad vibes from this hinge date, right? So let's send another signal to the brain saying, hey, I'm really not feeling good about this. After our conversations, we're just not vibing too well. And I'm starting to think that I might need some backup. So text sent to the brain. Then locally, you also start to have these cells within your small intestine that sense the glucose that can start the local response, right? And so we have cells in the small intestine that secrete GLP-1, which is what I feel like people are calling like the natural Ozempic. So when you hear the term Ozempic, we do also have a chemical in our body, a molecule in our body that helps to mimic that and helps to naturally control that. And so these cells within the small intestine are also sensing that change in glucose levels, send that signal right to the brain, send that text straight to your friend saying, hey, I've confirmed I'm getting a bad vibe on this date. Then you also have a local response where you're like, okay, I'm going to start doing things on my own right now because of this bad hinge date, right? So I'm going to start acting even more sick, like, oh, my stomach's really not feeling good, and just commenting more of those things. Similar to how the small intestine releases GLP-1 locally in order to help cue the insulin response, which is what we want when it comes to glucose regulation. And so GLP-1 has a few roles. It, again, natural ozempic. So it cues the insulin response, which is what we want after we notice or sense an elevation in those blood glucose levels. It inhibits glucagon, which I said earlier helps to mobilize glucose. So that's what we want when we're fighting a bear, when we need more energy. So it helps to inhibit that, which is also what we want. It helps to slow the transfer of the contents in the stomach to the small intestine. So by slowing the transport of the food from the stomach to the small intestine, we're leveling out that glucose spike. So rather than all of it being emptied into the small intestine, only a little bit at a time is being emptied. And so our body's able to control that spike rather than one all at once. It also, again, because of glucagon inhibits glucose mobilization from the liver. And then GLP-1 is secreted locally, but it's also can be broken down by a lot of the enzymes that are within the sort of digestive tract and that portal vein specifically where that glucose is. And so that's why we need that built-in redundancy. And so we start to complain about our stomach pain on this hinge date. We say, oh my gosh, I really need to get out. Our friends are already cued. They've already sensed it. The date starts asking more questions and starting to break down your response. Like, well, did you eat something? Can I do anything? Let's go get you medicine, and you're already like through with the date. You've already checked out. No, like bad vibes from the other guy. It's just not working out, right? And so he or she is starting to break down your response. But luckily, you've already sent that other message saying, hey, friends, I need your help. I need your reinforcements. And so GLP-1 does act locally, but it also cues the release of GLP-1 from the brainstem into the hypothalamus. And that hypothalamus in the brain can cue a more systemic response. So cues a more systemic release and a communication signal from the autonomic nervous system. And so with the GLP-1 release locally in the small intestine, we also have the GLP-1 release in the brain that helps to cue a wider spread global response throughout our whole body in the form of the autonomic nervous system. So the hypothalamus can be considered like your friends, right? They're the ones that are going to come in and create that global response. So in the hypothalamus, we have these glucose excited cells. So when glucose is high, these cells are excited, and that cues that parasympathetic nervous system to help release insulin in order to utilize the glucose or store it in short term or store it in long term. And so that's like the bad hinge date, right? We've sensed that glucose, our friends are coming in, they're like, okay, we need reinforcements, we need help. On the flip side, glucose inhibited neurons sense lower glucose levels, and that would cue glucagon in order to help mobilize more glucose in order to fight the bear or do that HIIT class or whatever it is. So the hypothalamus sends signals to the rest of our body via that autonomic nervous system to the liver, the pancreas, skeletal muscles, and then the adipose tissue, which are all the organs involved in either storage of glucose, utilization of glucose, or mobilization of glucose if we are in a lower blood glucose range. So your friends have come, they've saved you from a bad hinge date, but thank goodness you had both like a plan of action going in locally within yourself, but then also globally in the form of your friends. So I hope this sort of explains one component of the gut-brain axis in the form of glucose regulation and a bad hinge date. So there's so many more components of the gut-brain axis, but I think this is one of the ways that we can sort of really get a grasp on how interconnected our digestive tract is with the brain. And especially knowing that it's not just sensing our food in our digestive tracts that cues a response in our digestive tracts, but that eating food and having a sense of that glucose, those blood glucose levels, isn't just locally, but it's also globally. And so our brain is able to sense things sometimes even before our digestive tract, like internal, not the oral cavity, but our internal digestive tract is able to sense things. And that's shown with that 2 to 3 times increase in the insulin response with food being placed on the tongue versus with glucose injected via an IV. So I just think it's super cool. And I thought, a bad hinge date's maybe one of the ways that I can describe this being a local response and then also a global response. But the body having these built-in like redundant pathways is super good in a healthy system, in a metabolically healthy system, but it's not as great in a metabolically unhealthy system because we'll still have these processes go on, but sometimes it happens out of rhythm or out of sync with what we're actually wanting to happen within our body, especially when we have things like chronic inflammation, obesity, where it's been shown in, I believe, animal models, definitely animal models, maybe even human models, where that threshold has to raise in order for us to sense those glucose levels and then actually have that appropriate response. So redundancy in general is really good, and redundancy within our digestive system and managing glucose and managing our metabolism is really good. But we want to keep that sort of fine-tuned and be aware that anything that we eat has an effect on our brains as well. And so I think it's just a super cool link and one of the super cool ways that our body is able to regulate our metabolism in the form of food and then also signaling the brain. So super duper important too to have that just like healthy microbiome, right? Like we want our small intestine and our gut to actually be able to sense that change in those carbohydrates and those glucose molecules so that we can appropriately cue the brain. If that's wrong internally, then the signals are going to be off to the brain. And so it's sort of a compounded effect, which is why there's such a big emphasis on the gut-brain axis, the gut microbiome, digestive health. All of this stuff is because it's not just our digestive system, it's also our brain that's affected. So I hope you guys learned a little bit today. I hope having it be linked and mimicked with a bad hinge date helps you to understand it a little bit more. I know it helps me a little bit. And again, this is only scratching the surface. My blog post for the month of July, I believe, is going to be all about this. So if you're interested in signing up, it's a completely free newsletter. It goes out twice a month, once at the beginning of the month, once halfway through, where we just kind of update and send blog posts, sciencey stuff, podcast links, all sort of free stuff that I want people to be educated on and that I think is super duper cool in the human body. And in a way that the earlier we know these things and the earlier that we're able to implement things to help change it and help optimize it in our own bodies, I can only imagine the long-term effects that'll have on all of us, right? And so here's to healthy, just like sisters and misters for life, right? So I hope you guys enjoyed this podcast episode. Thank you for following along. If you haven't already, it would mean a lot to me if you could subscribe or follow along on whatever podcast or YouTube. Again, we do have this video on YouTube. And if you're interested in sort of joining the Ella Wellness Sisterhood, which is what I call like a wellness sisterhood, where we focus on things to help our skeletal muscle health, our overall like fueling patterns, our mindfulness, like basically a holistic wellness approach guided by me from actual science, not from, an influencer who just has a nice body, right? This is actually like science-backed things. And so if you're interested, I'd love to have you. We offer a 7-day free trial. I always leave the link in the show notes if you're interested. And if you have any questions, please reach out. I'd love to answer any of them, or I'd love any feedback or comments or different things that you guys want to learn about, or different components. If you're part of the sisterhood that you're like, hey Kelsey, can you make a video on this, or can you explain this a little more, or can we have a workout structure for this? I'd love to do that for you guys, because again, I'm building all of this for you guys, and I just want all of us to be empowered with what we know and how we're able to help our own bodies and build up those longevity funds for life, right? So thank you guys so much again for following along. I hope you liked this episode, and I'll see you guys again on the next Wellness Big Sis podcast.